Hey everyone, welcome to Unit 2. This unit is on logarithms. And for our first lesson, we're just going to talk about what is a logarithm. So logarithms are related to exponents. They're another way of expressing an exponential relationship. So we might be familiar with this form. This is called exponential form. And in this form, we have, what is called the base. So that number b, this is the base. We have an exponent. The number y is the exponent. And then this number x, I don't have a good name for this. I call it the answer number, because it's like the number you get when you do b to the y power. You actually do the exponent. Then you get an answer, and that's what x is. Okay, if we rearrange these a little bit, we can get a logarithm. So for logarithm, b, x, and y are still the same. So now the answer number is over here inside the logarithm. The base is kind of still where you would expect it to be, sort of like in a bottom position. And now the exponent is on the other side. So basically what logarithmic form does is it kind of flips the exponent and the answer number. In exponential form, we start with b to the y, and then we get x as our answer. In logarithmic form, we start with b and x, and then we get y, the exponent, as the answer. All right. I know that this probably seems really strange, but it will make sense. It's actually not hard. A few things to note about this. So first of all, this symbol is pronounced log base b of x. So I'd read this log base b of x. That's how you say that out loud. Okay, what is it? Log base b of x is asking for the exponent that you put on b to get x. That's what it's equal to. So if you are given a logarithm and you want to figure out what number it equals, there's a question you can ask yourself that will help you get the answer every time. Log base b of x, this is the exponent you should put on b to get x. So ask yourself, b to what power equals x? So we're looking for the mystery exponent here, right? On this side, we had the base and we had the exponent, and we were looking for the answer number. On this side, we have the base and the answer number, and we're looking for the exponent. The exponent is what's missing. So we're asking ourselves, b to what exponent, b to what power equals our answer number, x? And that will give you the value of the logarithm. Okay, I promise this is going to make sense when we do examples. So the first kind of two things I want you guys to be able to do is to switch between these two forms. So if you're given this form, flip to this form. And if you're given this form, flip back to this form. So we're going to start by practicing that. Okay, so for our examples, number one is where, oh no, I have this backwards. This should be logarithmic, this should be exponential. Oops, I'm sorry. Okay, so we're going to start by converting to logarithmic form. So we could start by saying, okay, this is the base, this is the exponent, this is the answer number. And remember, logarithmic form basically switches the exponent and the answer number. So now we're going to have a log. So log, we keep the base kind of in the same position, log base 2, and now we flip the sides for the exponent and the answer number. Now the answer number is over here on the left. So log base 2 of 128 equals, and it's equal to the exponent, 7. So log base 2 of 128. This is saying, what exponent do you put on 2 to get 128? And the answer to that is 7. Okay, let's try one more like that. So let's see, 625 is our answer number, 4 is our exponent, 5 is our base. So now we do the base, log base 5, and now we're going to flip answer number and exponent. So the answer number is going to come over to the left. Log base 5 of 625 is equal to the exponent, which is 4. All right, great. So logarithms are just another way of representing information about exponents. These two expressions communicate the same information. Okay, now let's try starting with a log and converting to exponential form. So log base 10 of 1,000 equals 3. 10 is our base, 3 is the exponent, and 1,000 is the answer number. So in exponential form, it would be 10 is our base, 3 is the exponent, so 10 to the third power is equal to the answer number 1,000. So this is what the logarithm means. Log base 10 of 1,000 equals 3 means 10 to the third power equals 1,000. Okay, let's do that one more time. So log base 3 of 6,561 equals 8. 3 is our base, 8 is the exponent, and 6,561 is the answer number. So this logarithm means that 3, our base, to the 8th power, the exponent, is equal to 6,561, our answer number. Okay, so that's kind of the first two goals, is just to be able to convert between the two forms. Okay, last thing we want to do for this lesson is actually evaluate logarithms. So if we're given this logarithm, can we say what it's equal to? And in order to do this, we're going to come back to this question. So to figure out log base b of x, we're going to ask ourselves, b to what power equals x? So if we want to do log base 8 of 4,096, what we want to ask ourselves is 8 to what power equals 4,096? Because remember, this, whatever goes here on this side, is an exponent. In the logarithm, this side is the exponent, right? So we want to answer this question. 8 to what power equals the answer number 4,096? You might be asking yourselves, how can you possibly figure that out? I want us to try to do it without a calculator, and I've given you guys a chart that can help you figure that out. So keep this in mind, 8 to what power is 4,096? So here's your exponent chart. Here's 8. Here's all the powers of 8 up to the 10th power. So like x squared, this is the second power of 8, 8 squared. Third power, this is the third power of 8. This is the fourth power of 8. This is the fifth power of 8, and so on. We were looking for 4,096. So it's right here. So 4,096 is the fourth power of 8. So this is basically telling me that 8 to the fourth equals 4,096, which means that the logarithm is equal to 4. The answer to our question was 4. 8 to what power equals 4,096? It's the fourth power. So log base 8 of 4,096 equals 4. Okay, let's try that again. So for this one, log base 9 of 531,441, this is asking 9 to what power equals 531,441. So we're just going to go back to our exponent chart to answer that question. Okay, let's clear off what we had. We want to find the powers of 9 now. And we were looking for 531,441, which is right here. And that is the sixth power of 9. So the answer to our question is 6, the sixth power. So that means this logarithm is equal to 6. And that's all there is to it. That's all there is to evaluating logarithms. Okay, let's do one more. So log base 2 of 512. We should ask 2 to what power equals 512. Okay, so we go to our exponent chart. Here are the powers of 2, and we want 512, which is right here. That's the 9th power of 2. So this logarithm is equal to 9. Okay, so that's the basics of logarithms, how to convert between the forms, and then how to use the exponent chart to evaluate them. And again, the key question is like the question 2 to what power equals 512. That's the key question to ask yourselves to evaluate a logarithm.